Okay, so now we start with vectors. And vectors are quantities that require a magnitude. In order to specify them, we need a magnitude and a direction. So scalars are those which require only a magnitude and do not require a direction. For example, temperature. Temperature may be 60 degrees or 70 degrees or 80 degrees, but there is no direction attached to it. It's just a value. But if we talk in terms of things like a force, then we should say that the force has a magnitude of, for example, 5 newtons, but in what direction? And so we say at an angle of 30 degrees with the positive x-axis. Now, if we don't do this, then we could have a situation where we have an object sitting on the ground, and if we apply this force this way, well, it's going to cause it to move to the right. But if we applied the force to the left, it would cause the object to move to the left. Or if we pushed it downwards, well, it's not going to move anywhere. So the value of the force is important, but also its direction, because the force causes some change in the state of motion of that object, and the direction of the force will tell us in which way it's going to create that change in motion. Now, when we write a vector, we normally use in textbooks a bold letter is used. So we write the letter A and it's written rather bold, or it could be a capital A but in bold. But when we're writing freehand or with the handwriting, then it's not so convenient to make it bold. In that case, when in handwriting, we normally write it as A with an arrow, or could be capital A with an arrow. And this arrow indicates that it's a vector. Well, normally the arrow takes a little bit more time, so sometimes people write it just as like this, or even just like that, and we know that that is a vector. It could be lowercase or could be uppercase. And when we want to draw the vector, then we draw a line of a certain length, make an arrowhead. So now this is an arrow. The length of the arrow is proportional to the magnitude, and the direction is the direction of the vector. So if we have, for example, 5 newtons at 30 degrees, it could be represented by this vector, and we call this vector A. That's the vector A. And if we have a vector B, which is, let's say, 10 newtons at, let's say, 90 degrees, then that would be represented by a vector that's twice as long. This is 5 units. This one would be 10 units long, so twice as long, and pointed in at an angle of 90 degrees with the positive, with the x-axis. Now, we'll look at some properties of vectors. So we'll look at vector addition as the first thing, properties. So the first property is vector addition.